Okay guys, so far when learning about factoring, we have the factoring cheat sheet, which looks like this. The first thing we need to look for is the greatest common factor. After we take out the greatest common factor, we need to ask ourselves how many terms are there. We can either have two terms or we can have three terms in the quadratic that we're trying to solve for. Now, if it has two terms, the only thing that it could possibly be is a difference of squares, which if you guys remember is factors into conjugates. If it's three terms, the first thing we learned how to handle was easy factoring, and we can use easy factoring if our a value is equal to 1. But what happens if our a value is not equal to 1? What do we do if there's a number in front of that x squared? Well, that's when we're going to do something called frowny face factoring, which is also called factoring by grouping. So let's look at an example on your worksheet. So I have 3x squared plus 8x plus 4. And I've gone through the factoring cheat sheet here, and there's no greatest common factor. I have three terms, and my a value is not equal to 1. So to frowny face factor, we need to multiply our a value by our c value. And you'll notice here it makes what looks kind of like a frowny face. And so my a value is 3 and my c value is 4. So when I multiply those together, I get 12. Now, similar to easy factoring, I'm going to find the factors of this number 12 here that add together to be 8. So over here I've listed the factors of 12, 1 and 12, 2 and 6, 3 and 4, negative 1, negative 12, negative 2, negative 6, and negative 3 and negative 4. And the two that add together here to equal 8 are 2 and 6. So those are the two factors that we're going to look at. Now, if this was easy factoring, I'd just be able to create my two binomials, stick in the variables, stick in the terms, and call it good. However, with frowny face factoring, we're actually going to rewrite my equation. And what I'm going to do is I'm going to leave my first term the exact same, and I'm going to leave my last term the exact same. But I'm going to replace my middle term here with the two factors that we chose. So 8 can be split into 2 plus 6. So I'm going to take that 8x and I'm going to split it into 2x plus 6x. Now it doesn't matter which one you put first. You can put 2x plus 6x or you can put 6x plus 2x. But what's important is that if I were to combine like terms here, if I were to take this 2x and 6x and add them back together, I would end up where I started with that 8x. So I'm not actually changing the expression. I'm just manipulating it to help us. So, step 1, multiply your a value times your c value to get 12. Find the factors of 12 that add together to be 8. Step 2, rewrite your expression with the factors being substituted in for your middle term. The next thing we're going to do is going to seem a little weird, but I want you to bear with me. We're going to group my terms with parentheses. So I want to put parentheses around my first two terms, which is 3x squared plus 2x. Then I want to put parentheses around my last two terms, 6x plus 4. So in this part, I didn't really change anything. I just put grouping symbols around it. But what I want you to notice is that there's an addition sign in between my parentheses. That's very important. Now I'm going to look at each binomial and look to see what they have in common. So if I focus on this first binomial here, 3x squared plus 2x, if I were to ask you to factor out the greatest common factor between these two terms, we could start with the coefficients. 3 and 2 don't have a greatest common factor, so I can't take anything out there. X squared and x, however, both have an x in common, so I can factor out an x. Now let's see what I have left. 3x squared divided by x leaves me with 3x, and then 2x divided by x leaves me with 2. Now we're going to do the same thing to my second binomial, 6x plus 4. I want the GCF between 6 and 4, so they're both even, and the highest number that can go into them is 2. And let's see what I have left. 6x divided by 2 gives me 3x. 4 divided by 2 gives me 2. Now at this stage, if you look very carefully, hopefully you'll notice that the two binomials are exactly the same, and that's what we want to happen. If that happens, you are on the right track. Now, we're going to factor again. If those two binomials are the same, we're going to write that one first. We're going to take that binomial out, and then our second binomial, what we're left with, is whatever was in front of the binomials to begin with. So my first term here was an x being multiplied by this binomial of 3x plus 2. But if I take out that 3x plus 2, I'm only left with that 1x. So you don't have to put the 1 there, but I am, so you guys can see what I'm talking about. Now my second term here was this 2 being multiplied by the binomial of 3x plus 2. So if I take away that binomial of 3x plus 2, that leaves me with just the 2, which can come down here. So when you're frowny face factoring, it's a couple more steps. It's not just as simple as if we were easy factoring. So let's give it a shot on number 1. I have 2x squared plus 13x plus 6. So the first thing I want you to do is check to see if there's a greatest common factor. So 2, 13, and 6 don't have anything in common. And x squared, x, and no variable, so I can't take out a variable. Next, according to our factoring cheat sheet, we ask how many terms are there. We have 3 terms, so I want to see if my a value is 1, so I can do easy factoring. Well, here my a value is 2, so I cannot easy factor. My a value, since it's not equal to 1, means we have to frowny face factor, so here's what we're going to do. We need to start by multiplying your a value times your c value, so we need to draw the frowny face, and 2 times 6 is 12. Then we need to find the factors of 12 that add together to be 13. Well, two numbers that multiply together to be 12 and add together to be 13 are 1 and 12. And I want you guys to write them over to the side here so you can do your mental check. 1 times 12 is positive 12. 1 plus 12 is 13. So those are the factors we need. Now what we're going to do is we are going to rewrite the expression. So I want you to start by taking our first term and bringing it down. That doesn't change, 2x squared. But instead of 13x here in the middle, we're going to replace it with 1 and 12. So I want plus 1x plus 12x, then bring down your last term, plus 6. Now again, it doesn't matter which order you put those in. If you put plus x plus 12, that's correct. If you put plus 12x plus x, that's also correct. So order does not matter when substituting into the expression. Next, what I want to do is I want to group my binomials. So a parenthesis around the first two terms, 2x squared plus x, and parentheses around your last terms, 12x plus 6. It's very important that we have an addition sign in between the parentheses. We don't want multiplication, we don't want subtraction, we want an addition sign in between the parentheses. Now I'm going to go through and look for the greatest common factor in each binomial. So in my first binomial here, 2x squared plus x, if I look at the coefficients, 2 and 1, we don't have a greatest common factor there. But if I look at the variables, x squared and x, they both have an x in common, so I can take out an x to the first power. Now let's see what I have left. 2x squared, take away an x, leaves me with 2x, and x divided by x leaves me with 1. Now we do the same process to my second binomial. I want to see what the greatest common factor is between 12x and 6. So 12 and 6, both are even, but the biggest number that can go into both of them is 6. So I can take out a positive 6. And let's see what I have left. 12x divided by 6 is 2x. 6 divided by 6 is 1. At this point, I want you to stop and look at what we have in our binomials. My first binomial is 2x plus 1, and my second binomial is also 2x plus 1. They're the exact same, which is what we're wanting. So since they are the exact same, we're going to bring them down, and that's what we write first, that 2x plus 1. Now, my second binomial is whatever was in front of my binomials. So in front of my first 2x plus 1, I had x, so that's my first term here. In front of my second binomial, I have a plus 6, so that's what's going to go second here. That means that 2x plus 1 times x plus 6 gives me 2x squared plus 13x plus 6. And if you don't trust me, you can always check by foiling. 2x plus 1 times x plus 6, and I can say first gives me 2x squared, outside gives me 12x, inside gives me x, and last gives me 6. So, combining like terms, I get 2x squared plus 13x plus 6, which is exactly what I started with. So, the process is multiply your a value times your c value, find the factors, rewrite your expression and group it, take out the GCF, and find your two binomials. Let's try it again on number 2. First thing on number 2, I want you to multiply your a value, which is 3, times your c value, which is negative 5. So 3 times negative 5 gives me negative 15. Now we need to find the factors of negative 15 that add together to be a positive 2. So if you need help, you can always list the factors of 15, 1 and 15, 3 and 5. But since it's actually a negative 15, we know that one of the numbers has to be negative. Now when I add them together, I end up with a positive 2, so that means my bigger number has to be positive. Now negative 1 plus 15 gives me positive 14, so that's out. Negative 3 plus 5, though, gives me a positive 2. So those are the two factors that I want to work with, negative 3 and positive 5. Again, I want you to write those factors down so I know what factors you're working with and so you can do a double check. So negative 3 times 5 is negative 15. Negative 3 plus 5 is positive 2. Next, what we're going to do is rewrite my expression. So first term comes first. I'm going to replace this 2m with my two factors. Now again guys, it doesn't matter which number goes first, whether it be the negative or the positive. However, for simplicity's sake, I need you to trust me on this, it is much easier to solve, it is much easier to work with if you put the negative factor first. So I want the negative 3m to go first and the positive 5m to go second, and then we can bring down my minus 5. Next, we're going to group our two binomials. So I want parentheses around my first two guys and parentheses around my last two guys. And again, it's very important that you have an addition symbol in between them, not subtraction. We want addition. Now we can take out the GCF. So 3m squared minus 3m. Both of my coefficients are 3, so a 3 can come out. And both terms have an m, so I can bring out an m. Now let's see what I have left. 3m squared divided by 3m just leaves me with m to the first power. Negative 3m divided by 3m leaves me with negative 1. Now my second binomial, 5m minus 5. They both have a 5 in common, so I can take out a positive 5. And that leaves me with 5m divided by 5 is m, negative 5 divided by 5 is negative 1. Now let's see what I have in my binomials. My first binomial is m minus 1, and so is my second. If they're the same, that means you did it correctly. So bring that m minus 1 out front, and then let's see what I have left. My second binomial starts with this guy, so 3m, and ends with this guy, plus 5. Let's try it again on number 3. Start by multiplying your a value times your c value. So 7 times 2 gives me 14. Now we want the factors of 14 that add together to be negative 15. So negative 1 and negative 14 are what we want. You can always double check. Negative 1 times negative 14 is positive 14. Negative 1 plus negative 14 is negative 15. Now we can rewrite our expression. So I'm going to start with my 7r squared, and I want to replace this guy with these two terms here. Now I want the negative factor to go first. However, if they're both negative, here's what we do. I'm going to start with my negative 1, so that's going to be negative 1r. And instead of saying minus 14r, to make it easier, I want you to say plus negative 14r. Then bring down your plus 2. Now we can go through and group. So 7r squared minus r, and then a negative 14r plus 2. And the reason we want the plus negative 14r instead of minus 14r is because that gives me a plus sign in between my two binomials. Now again, guys, it has to be an addition sign, not subtraction, not multiplication. Now we can go through and take out the greatest common factor. So the greatest common factor between 7r squared and negative 1r is just going to be that r. There's no coefficient in common here. So 7r squared divided by r gives me a 7r, and negative r divided by r gives me a negative 1. Now on my second binomial, if you'll notice here, my first term is negative. When that happens, you need to factor out a negative number because we never want that first term to be negative. We always want it to be positive. So we want to find the GCF between 14 and 2, which is 2, but instead of factoring out a positive 2, I want to factor out a negative 2 to make that negative sign go away. So now let's see what I have left. Negative 14r divided by negative 2 is going to be a positive 7r. Then a positive 2 divided by a negative 2 gives me a negative 1. Since I factored out that negative sign, now my two binomials are the same, which is good, and that can come out first. Now whatever's left in front of them is what's my second binomial, a 1r and a minus 2. Let's look at number 4. I have 4x squared minus 26x minus 48. Now don't forget, when you're factoring, the very first thing we're supposed to be looking for is a greatest common factor. So if I look at number 4, 4x squared, 26x, and negative 48, they all have a common factor of 2. So I'm going to take out that 2 first and see what I have left. So if I take out a 2, 4x squared divided by 2 leaves me with 2x squared. 26x divided by 2 leaves me with a 13x. And a negative 48 divided by 2 leaves me with a negative 24. Now, inside of my parentheses, I can keep going. My a value is not equal to 1, so I have to frowny face factor. So I'm going to multiply 2 times negative 24 to get a negative 48. And let's find the factors of negative 48 that add together to be positive 13. So go ahead and pause the video, find 2 factors that multiply together to be negative 48 and add together to be positive 13. Hopefully you got those 2 factors to be negative 3 and positive 16. Now what we need to do is we need to rewrite what's in green here, but we don't want to forget this GCF that we took out. That needs to come along with us for every step. So I'm going to start by bringing down my 2 and opening my parentheses. Then I'm going to rewrite this expression and replace that positive 13 with a negative 3 and a positive 16. So I'm going to bring down my 2x squared. And again, it doesn't matter which one goes first, but to make it easier, we want the negative one first. So minus 3x plus 16x, and then bring down my negative 24 and close my parentheses. Now, inside of my parentheses, I need to group my 2 binomials. So I want 2x squared minus 3x and 16x minus 24 with an addition sign in between. Now at this point, it might be a little hard to see what's going on because we have so many parentheses happening inside of our work. So to make this easier, I'm going to teach you a trick to help keep your work visually organized. When taking out a GCF when you're factoring, it's much more beneficial that instead of putting parentheses, let's make them brackets, because that kind of shows that this is the major set of parentheses and everything on the inside is grouped together. So when factoring, every time I take out a GCF, I'm going to use brackets instead of parentheses in order to keep my work organized. Now the next step that I need to do is I need to take the GCF out of each one of these binomials. So the first thing that needs to happen is you bring down the 2 that you've already taken out and open up your bracket. Now let's look at my first binomial, 2x squared minus 3x. The greatest common factor between 2x squared and negative 3x is just an x. And that's going to leave me with 2x squared divided by x is 2x, and negative 3x divided by x is negative 3, so 2x minus 3. In my second binomial, I have 16x minus 24. So I need to find the greatest common factor between 16 and 24. Right off the bat, my first guess would probably be 4. So if I factor out a 4, that's going to leave me with 16x divided by 4 is 4x, and 24 divided by 4 is negative 6. Well, if I look, guys, my binomials are not the same. That means I did something wrong. So let me try that again. Maybe I didn't take out the biggest factor that was possible. So 16 and 24, if I need to, I can always come over here and list my factors. And then I have 24, which is 1 and 24, 2 and 12, 3 and 8, 4 and 6. Now the biggest number that they both have in common is 8. That means my GCF that I can take out here is an 8. And 16x divided by 8 is 2x. 24 divided by 8 is negative 3. And then you can close your bracket to make sure you know everything that goes inside of it. Next, we need to see if our binomials are the same and what we can take out. So 2x minus 3 and 2x minus 3 are the same. That means they can come out. But first, bring down your greatest common factor of 2. Now you don't need the brackets on the last step because you're just writing down your answer. So the GCF is first. The binomials that are in common are second. And finally, you just write what's left. What was in front of the first one was x, and what was in front of the second one is 8. Now the next problem we're going to do is number 6. I want you to skip number 5. Let's go to number 6. I have 8x squared plus 5x equals 3 plus 7x. On this one, be aware that we have an equal sign, and that means we need an answer instead of just factoring. So we need to start by setting everything equal to 0. So I want to subtract 7x to this side, and I want to subtract 3 to this side. So I'm going to bring my 8x squared down because that hasn't changed. When I subtract 7x, 5x minus 7x gives me negative 2x. And then when I subtract 3, I'm going to get minus 3, and that leaves equals 0 on my right side. Now I can go through my factoring cheat sheet here. There's no greatest common factor. I have 3 terms, and my first term is not equal to 1. So I need to take 8 times negative 3 and frowny face factor. So 8 times negative 3 is negative 24. What I'd like you to do now is pause the video and find the factors of negative 24 that add together to be negative 2. Hopefully you found those factors to be negative 6 and positive 4. Now I can rewrite my equation with these factors in place of the negative 2. So 8x squared, I want the negative 1 to go first, minus 6x, plus 4x, bring down my minus 3, equals 0. Next, we group my terms. So 8x squared minus 6x, plus 4x minus 3. Next, we can take out the greatest common factor. So 8x squared minus 6x, the greatest common factor between 8 and 6 is going to be 2. And then I can also take out an x since both terms have one. And 8x squared divided by 2x is 4x. 6x divided by 2x is 3. Now with my second binomial, 4x minus 3. 4 and 3 don't have any greatest common factors, and 4x has an x, but 3 doesn't have an x, so I can't take out a variable either. So at this point, it might be a little worrisome as to what we're taking out of 4x minus 3. But I want you to remember, if I were to list the factors of 4 and the factors of 3, even if they don't have a greatest common factor, they really do, and it's actually 1. Now you guys know as well as I do that if I take out a 1, nothing really happens, but since we know that whatever is in front of the binomials comes down to make my second binomial, it's important that we put that 1 there even though it doesn't do anything. So when I take out that 1, I'm still left with that 4x minus 3. Then I can bring down my equal 0. Now the two binomials that I have in common are 4x minus 3 And then I'm left with the 2x in front of this guy and the plus 1 in front of that guy. So that leaves me with 4x minus 3 times 2x plus 1 equals 0. Now, I have to keep going because now we have an equal sign that's set to 0, so I need to get my two solutions. So remember, to do that we use the zero product property. We take my first term here, which is 4x minus 3, and we set that guy equal to 0. Then I take my second term here, which is 2x plus 1, and I set that guy equal to 0. And at this point, we just solve like normal equations. So on this guy I would add 3 to each side and divide each term by 4, and I get 3/4. And on this guy, I'd subtract 1 from each side and divide each side by 2, and I'd get negative 1 over 2. So my solutions are 3 over 4 and negative 1 over 2. Alright, next I want you to skip number 7 and we're going to look at number 8. Again, we need to set him equal to 0 by adding the 12 to each side. So that gives me 2m squared minus 11m plus 12 equals 0. Then I want to look for a greatest common factor. So 2, 11, and 12 don't have a GCF. 12 doesn't have a variable, so there's no GCF. Next, I want to ask if my a value is 1. Since it's not, I need to do frowny face factoring. So we're going to take 2 times 12 to get 24 and find the factors of 24 that add together to be negative 11. Pause the video, find those factors. Hopefully you got the factors to be negative 3 and negative 8. Now I rewrite. Bring down my 2m squared. Replace negative 11m with negative 3 and negative 8. But remember, we want them to have an addition sign in between. So if I bring down my minus 3m, instead of bring down minus 8m, I want to put plus negative 8m. Then bring down my plus 12 and set it equal to 0. Now we can group. Parentheses around 2m squared minus 3m and parentheses around negative 8m plus 12. Double check that you have an addition symbol in between your parentheses. Next we take out the greatest common factor. So 2m squared minus 3m. The GCF between those two is just m. And let's see what I'm left with. 2m squared divided by m leaves me with 2m. And negative 3m divided by m leaves me with negative 3. On my second term here, I have negative 8m plus 12. The greatest common factor between 8 and 12 is 4. But since my first term here is negative, that means I need to factor out a negative sign as well. So negative 8m divided by negative 4 is a positive 2m. And a positive 12 divided by a negative 4 is a negative 3. Then don't forget your equal 0. At this point, our two binomials are the same, which is a good sign. That can come out first. And what I'm left with is this m here and this minus 4 here. And again, we can set that equal to 0. Finally, my last step, I need to take each term and set that equal to 0 to solve. So 2m minus 3 is going to equal 0, and m minus 4 is going to equal to 0. So why don't you guys pause the video and solve to get your two final answers. Hopefully you'll add 3 to each side and divide by 2 to get 3 halves. And here you'll add 4 to each side and you'll get a positive 4. So my answers are 3 halves and positive 4. Now on the last two problems, we're going to get some practice going through the factoring cheat sheet so you guys understand what I'm talking about. So on number 9, I have x squared plus 10x plus 9. Now the first thing that I want to look for is the greatest common factor. So I have a 1, 10, and 9, which means I can't take out a coefficient. I have an x squared, x, and no variable, so I can't take out a variable. Next thing I need to ask is how many terms are there? Well, I have 1, 2, 3 terms. So now I need to look at my a value. Since my a value here is 1, that means we are going to easy factor. Now just a reminder, easy factoring is only finding the factors of your c value that add together to be your b value. So if I were to list out the factors of 9, I have 1 and 9 and 3 and 3, and the two that add together to be 10 are 1 and 9. So all we have to do is break up our trinomial into two binomials. The first term in each binomial is the variable that you're using, so x. The second term in each binomial are your factors, a positive 1 and a positive 9. Now we bring down our equal 0. So I have the quantity of x plus 1 times the quantity of x plus 9 equals 0. Now, by the zero product property, we can take x plus 1 equal to 0, x plus 9 equal to 0, and solve. So go ahead, pause the video, and get your two answers. Hopefully, you get -1 and -9. On number 10, again, if we go through our process, first of all, I want to see if there's a greatest common factor. So the factors of 81 and 4, let's list the factors of 4 first. I have 1 and 4 and 2 and 2. Well, 81 is odd, so 2 can't go into it, and 4 can go into 80, so if I take 81 divided by 4, it also doesn't work, so there's no greatest common factor. The next thing we need to determine is how many terms are in this expression. So 1, 2 terms means that this is a difference of squares. Now to be a difference of squares, your first term has to be a perfect square, your second term has to be a perfect square, and it has to be separated by a subtraction sign. To factor, it breaks up into conjugates. Now to find the first term, we need to take the square root of our first perfect square. So the square root of 81 is 9, and the square root of x squared is x, so I have 9x. Now I need to take the square root of my second term here, 4. Now the square root of 4 is 2, and then 1's going to be plus, and 1's going to be minus, and I can set those equal to 0. Now I can take 9x plus 2 and set it equal to 0, and 9x minus 2 and set it equal to 0. Now pause the video and finish this problem. Hopefully you got answers of -2 over 9 and +2 over 9.